Okay, so hello and welcome to this video tutorial for E411, Statics and Dynamics of Simple Mechanisms. So we have this problem here, problem 9. It is a problem where the underlying concepts are quite simple, but the technique in solving it is actually can actually get quite fluffy. Let's start though, as you would typically start with a problem like this by drawing a free body diagram. So first of all, we have this F2 force here. We have this F1 force here. Oh, it's not going to give me a straight line. Oh well. We have this 5 kilonewton force here. And we have this 7 kilonewton force down here. Let's add some of the geometry to this then. So we've got, let's add the horizontal in here. Right, so we've got this 30-degree angle with the horizontal here. We've got this 20-degree, I know it says 70 with the vertical, but I'm just going to be consistent and describe it as a 20-degree angle there. A 60-degree angle here, theta is given as 60, and we've got a 3, 4, 5 triangle here. 3, 4, 5. So it's understood that this system is in equilibrium. So we can say that the sum of the forces in the horizontal and in the vertical are equal to 0. Let's start by resolving horizontally first. So let's consider things moving to the right. We've got F2 cos 20. Please don't do that. F2 cos 20 plus F1 cos 60. And acting to the left, we've got this 5 cos 30 component and this 4/5 of 7. Excellent. Is this solvable? No, because it's got 2 unknowns in it. So let's move on then and resolve vertically. So let's start with things going up. Things going up then include the vertical component of this F2, so F2 sine 20, and the vertical component of the 5 kilonewton force, so 5 sine 30. Things going down then, we've got the vertical component of the F1 force, F1 sine 60, and the vertical component of that 7 kilonewton force, which is 3/5 of 7. Okay, is this problem solvable now? Yes. We still have 2 unknowns, F1 and F2, but we have 2 independent equations. If we have as many independent equations as we do unknowns, then it's solvable. So the reason why this can get quite fiddly is because at least notationally, it can get quite fiddly is because we've got a number of trigonometric terms here. We've got this cos 20, this cos 60, this cos 30, this sine 60, this sine 30, this sine 20 here. So it might make sense to simplify. So what I've kind of, I'm going to do a blue Peter here and show you what I've done earlier. This right-hand side here, I can simplify down to 9.93. And what I can do, I can take this F1 sine 20, move all the terms containing an F over to the left and all the terms not containing an F over to the right. So I can rewrite this equation. On the left-hand side, I'd still have F2 sine 20, but I'd have moved over this F1 sine 60 term. And I will have subtracted 5 sine 30 from both sides. And when I take 3/5 of 7 and subtract 5 sine 30 from it, I get 1.7. So this helps simplify things down a bit now. Our two equations we're working with here we can consider this the left-hand side and this the right-hand side of equation 1. And we can consider this equation 2. Awesome. Okay. We could simplify it even further, right? We could bung sine 20 into our calculator, determine its numeric value, same for sine 60, and these trigonometric terms here, and rewrite the equations. That is perfectly valid. If you want to do that, then absolutely go ahead. However, sometimes I like to just press on. Sometimes I like to keep the trigonometric terms just as they are. I'm going to approach this problem using substitution. So I'm going to take equation 1, and I'm going to rearrange it for f2. So I'm going to say f2 is equal to 9.93 minus f1 cos 60 all over cos 20. Wonderful. And I'm going to substitute that into equation 2. So, still getting used to this pen. Here we go. I'm going to substitute it in there. What's that going to look like? It's going to look like this. So 9.93 minus f1 cos 60 all over cos 20 times sine 20 minus f sine 60 is all equal to 1 point. I should have written f1 there, just so I know which one I'm working with. Is all equal to 1.7. This problem should be solvable now. I'm going to also rewrite this term. Some of you may have noticed it's something that we've done before, this idea of this quotient identity. So this sine 20 over cos 20 is a trigonometric identity some of you may be familiar with, where we can say that, let's write it the other way around, we can say that the sine of an angle over the cos of an angle is always equivalent to the tan of an angle. So I'm going to rewrite that term. I'm just going to describe it as tan 20 times this numerator. So 9.3 minus f1 cos 60 minus f1 sine 60 is equal to 1.7. Okay. Let's go ahead and solve this then. So I'm going to want to take all the terms containing f1 and move them onto one side, and all the terms not containing f1 and move them onto the other. So I'm going to do this step by step. I could skip steps here, but I'm going to show all the workings. So I'm going to start by expanding this bracket here. 9.93 tan of 20 minus f1 cos 60 tan 20 minus f1 sine 60 is equal to 1.7. Okay, so like I said before, all the terms containing f1 onto one side, all the terms not containing f1 onto the other, and I'm going to factorize. So on my left-hand side, I'm going to say 9.93 tan 20 minus 1.7 is equal to, I'm going to move these terms over to the right-hand side, and I'm just going to factorize all in one step. So I'm going to say f1 cos 60 tan 20 plus f1 sine 60. And then finally, I can say, therefore, F1 equals 9.93 tan 20 minus 1.7 all over cos 60 tan 20. I've written that wrong. I didn't need to write the F1 there at all. Apologies. Plus sine 60. Now, when I go ahead and bung that in my calculator, 9.93 tan 20 minus 1.7 all over cos 60 tan 20 plus sine 60. I find that's equal to 1.8. 1.8 kilonewtons. So that's my F1. Now, I expressed F2 in terms of F1 earlier. Where did I do it? I did it here. Right, so I'm just going to drag that down. Let's zoom out a bit here. So I can say then that F2 is equal to 9.93 minus 1.8 cos 60 all over cos 20. And when I bung that in my calculator, 9.93 minus 1.8 cos 60 over cos 20, I get 9.6. Oops. I get 9.6 is equal to 9.6 kilonewtons.